made out of horses.
Ah, we're being recorded.
Whatever you say, maybe held against you.
Oh, I was going to court.
I'm gonna try to record this one. We'll see if it's gonna work or not with my iPad.
Is it spicy? Oh,
All right, did everybody? Let's see, you got 11 people, 2 more people. You're gonna vote on the poll.
I
Looks like so far we're doing a quiz bowl,
Hey,
No,
Miss
no,
Tara, I want my
no.
little sticker. I voted.
but
oh.
yeah,
Your
that's
little
Oh, yeah.
sticker.
Little sticker.
But the quiz bowl will be a team event, so you don't have to know everything. You can rely on team members.
Whose number is that? Don't make me call it.
Oh no. I wonder.
I should call it right now.
No.
Here's your paper strips.
Is that Emma? Nah, bro, there's 2 of you.
What?
Nah.
What have they done?
Why was there 2 of me? I didn't see 2 of me.
Bro, she found the infinite diamond glitch and she duplicated herself.
All right, I'm gonna end the poll.
I'm gonna call it right now.
Don't do that. Don't do it, man. No.
Whose phone number is
Actually,
it?
next week.
You
Yo,
call
quick.
them
Hey,
Yay.
Oxford, guess what? Guess what?
Yeah.
Geology unit failed. It is.
What the?
You came Among Us at 3
Okay,
a.m.
so there we go. Looks like
Nah,
Quiz
bro.
bowl.
Don't be
Quiz
trolling like that.
bowls.
Levi, what phone number was that?
Are you calling Among Us at 3 a.m.,
It was
dude?
a random
Alright.
one. Just
Whose
watch.
phone
I
number
just
was
chose.
that?
I just chose a random phone number.
No, because it's an actual phone number.
Uh-oh.
yes.
She just called. Uh-oh.
Instead it's
All right,
gonna
is
be
everyone
recorded for
ready
quality,
science?
quality,
It's science time.
quality or
I know.
something.
All right, this is going to end our nuclear chemistry unit. We're still going to do some nuclear chemistry, but we're going to bring it back to Earth today. All right, so nuclear chemistry and Earth. All right, let's see. I'm going to seriously. Oh, are you doing chat? All right, let's see. I'm gonna slowly
What are you doing?
transition. We got 14.
Why do I have so many emojis on my message?
All right, let's see.
I'm back.
All right, guys.
Wait, can I get a pencil real quick?
Earth
Yes.
is a planet.
Did not know that.
I did not know that.
Wow, Levi. Earth is a planet.
No,
No, it's
Earth
not.
as a planet.
I thought Earth was a star.
Yeah,
Earth is-
same.
Earth
Earth is a star.
Earth's a star.
The star,
Bro.
yeah.
I'm pretty sure it's a star.
Yeah, I'm pretty sure it's a star too.
I mean, a star is a big ball in space. The Earth
Who's
is a big ball in
drawing?
space.
Bro, Miles is just griefing the screen.
Testing. There you go. All right, is everyone ready to bring it all back home?
Can I,
Yes.
okay.
No.
Grace is the only one who said something.
Nah, bro. Okay, Levi. You know how tempting this is? Levi, you have a 218 number. That's a Houston number. I'm gonna be calling someone around Houston. What is that number before I call it? It better not be emergency services, bro.
Oh
All right, you
no.
got it down.
Yes.
If it's
All right,
emergency
everybody.
services,
I
I'm
think that's
screwed.
Levi's phone number. I think that's Levi's phone number.
Oh, that's
Hey,
Levi.
Levi.
Okay.
Levi.
No, it's not. Yes.
Can you change it back? It's causing a disturbance in the force.
Okay. Okay.
Oh no.
Thank you,
Oh,
sir.
I didn't know
Hi,
that was there.
teacher.
Oh, I'm gonna screenshot it. I'm gonna call it later.
All right.
Okay.
So let's talk about
I'll never
Earth
be
as a
that
planet.
later.
I'm
I never
hoping
can.
everybody can see my screen share, correct?
Yeah, we
Yes.
can.
Awesome. All right, so we're gonna answer a couple questions for me today.
Correct.
What do
What?
we need to stay alive in space?
Ben and Jerry.
Fortnite.
Ice
That's
cream.
good. That's good to do. We need to do that.
Ice cream and Netflix, is that correct?
Yes.
No.
Yes.
We need to
Yes.
eat
Ben
that.
and Jerry's is the best ice cream.
It's that Space Force
Stay by
Netflix.
that till I
We
die.
love our
Well,
Earth.
I get
It is our
bad
planet.
internet there.
All right, so what do we need to stay alive in space, guys?
Ben and Jerry.
Oxygen.
This is right
Atmosphere.
Well,
Water.
those are some of my suggestions. I mean, what do we need really?
Oxygen.
Water,
I just
food,
said that.
shelter.
Okay, we
Terrain.
need some water.
We need Earth to live.
Atmosphere. Air
Yes.
pressure.
Live, that is
For
it.
real.
I'm reading it off the screen.
And we need Ben and Jerry's ice cream. Don't forget about that.
Okay, so let's make a little list here. So if you design a spacesuit, right? How are we designing it? What do we need?
Make sure that it is able to breathe.
Okay, so we need oxygen, right? Because what is our atmosphere made up of?
Oxygen, hydrogen, and
Nitrogen.
nitrogen.
Mainly nitrogen, right? Okay, so we don't really need that. We just need oxygen, right? We need 550 liters per day. So if you have lack of oxygen, that's called hypoxia, right? So you don't have long to live, right?
Oh, there's actually a disease for that?
Oh yeah.
It's
You
like
can ask
chicken pox.
your lovely mother what hypoxia is. She would probably know. Working in the medical field. All right, we need some water. How about 70 degrees Fahrenheit temperature, right? Like a nice temperature. We're definitely gonna need a spacesuit when you're gonna need some food.
And,
Clothes.
probably.
Do you think a sword is a good thing to bring to space?
Yes.
No.
Well,
A
you
sword.
need to fight the space monsters.
You gotta
The
fight
space
the aliens.
aliens.
Don't tell me you have a
Gotta fight the
katana.
aliens.
Defend off the. Then you can.
Personally, I
defend
don't think
off
we need to
the-
breathe oxygen.
No.
Yeah,
let's
and-
talk about
Is
it.
it atmosphere? Do we need an we need an
right.
atmosphere?
So why do we care?
We're
Why
reading.
am I asking you guys about what we need in space when we're talking about Earth?
You're making
Because
sure
so that
we
you
know
know
what
what
we
we
need to
have
bring
on
us
Earth.
that's out in space.
No, they're bringing a lot more oxygen than nitrogen on the space.
Earth
station.
kind of tells us what things need to live, right? So we kind of need to bring those conditions with us somewhere else, like when we had to terraform Mars a couple units ago, and when we're going to land on the moon, we need to actually make an Earth-like
I don't know. We haven't landed.
container for us to walk around in, right?
Wait,
Okay, so how does breathing work? All right, so we have our nitrogen, our oxygen, and then what do we exhale?
Carbon dioxide. and other stuff.
Nitrogen.
Yeah, so carbon dioxide is a toxic gas. So we're actually expelling toxic waste, right? What happens if we have too much CO2 in the air?
We all
turns
can't
green.
breathe it.
We just
Yeah, 1% we get kind of dizzy and disoriented. If we have 8%, we die. So we're kind of machines that spit out toxic gas.
wait,
right?
wait a second. Wait. If you breathe in 100% oxygen, wouldn't you die?
You would not die. You only die with the toxic gas we breathe out, CO2.
well, then I have a question. Why do we
Yes.
breathe more than 3/4 of the oxygen just right back out?
We only need a little bit of it, right? Our
Why don't we
bodies
just-
can only take in so much oxygen.
Then
We
how come
use
we don't just
goes
like keep
through-
it in our lungs? We just keep it in our
Right,
lungs till
so
it's gone.
remember when we did our biochemistry unit and remember how the hemoglobin in the center has iron? And that iron in the center of our hemoglobin actually takes in that oxygen. And so we only have so much of hemoglobin to actually bring in oxygen to our bodies.
Oh,
Okay, so
that makes sense.
when we leave our atmosphere, right, we need oxygen. Well, the brilliant people at NASA found out through chemistry that you can use a lithium hydroxide filter. Okay, so chemically it will combine with CO2 to filter out CO2 in space. So as we're this being that breathes out this toxic gas that will kill us, we need a filter to filter that away. Now on Earth, what's our filter for our toxic gas?
Our lungs.
Trees.
Oxygen breathes. Oh, lungs.
Trees.
Trees. Someone said
Oh.
trees. So
But
it's
nobody said
actually
trees.
Trees.
anything that photosynthesis will take in, right? Because what's photosynthesis? What does it take in?
Carbon dioxide and turns to oxygen.
It takes that. That's right. So we're these beings that breathe out this toxic gas that will eventually kill us, right? But we have things that can use photosynthesis to take up our toxic gas and then expel oxygen for us. Okay. So we need to, there's no trees in space, right? Or plants or plankton. So we need a filter that will do that.
We need to
So
grow some.
we need chemistry. That's right. You can grow some. We need some atmosphere, right? Okay. Here's an awesome, have you guys ever seen the movie Apollo 13?
No, but I've seen.
No.
Okay, so
have.
this actually happened in Apollo 13. It's a great movie if you guys want to watch it. But the lithium hydroxide filters on the spacecraft
Bro,
ran out. So although there was plenty of oxygen to breathe, the issue is we're breathing out toxic CO2. Okay, so this is a little clip from the movie on that. Can you guys hear it?
Yeah.
Yes.
Yeah, CO2 filter problem really much.
It's very low frames per second, but I can hear it.
I can barely hear it.
Over 15, you get air judgment, blackouts.
that lag.
I can barely hear it, but I can't hear it.
Okay, if
Yeah,
you
when
can't
it
hear it,
fails.
I'm gonna put it in the
I could hear it, but the frames.
our YouTube video thing. Okay, so essentially Apollo 13, they had to figure out how to make a filter, a lithium hydroxide filter, out of the things on the spacecraft, and they had to do it fairly quickly or they were all going to die. Okay, so too much of our toxic waste or gas that we breathe out is bad, right? So this is the actual filter that they built on Apollo 13. It's really cool. That movie's awesome. Okay, so if CO2 is bad, what about too much oxygen?
It's probably, it can probably make you pass out or
It
something, but
will
it can't kill
suffocate us.
you. It can't kill you.
Yes, it can.
Yeah.
No,
Didn't Miss Tara already
oxygen's
say
great
it
for
can't
us,
kill you?
right? We can have oxygen,
It's
right?
it's too much of a good thing.
Well, humans
of a-
like oxygen, right? Like if you're again, Miss Jen would know this in the medical field, but they put
yes.
oxygen masks on you, right?
It's like 100% oxygen in there.
Oxygen. The astronauts in the ISS, it's pure oxygen. Okay, but what happens here on Earth if there's too much oxygen?
Green.
No,
Turn the ocean green.
Plants die.
plants don't like oxygen, right? That's their waste.
Plants
Plants
don't
want
like oxygen.
CO2. Okay,
Hey, that was stuff
So-
like global warming because we never get it
So-
back.
billions and billions of years ago. Okay, this is when the Earth was just molten, right? And nothing but volcanoes and lava and hotness. It eventually cooled, okay, and our oceans formed. Well, there are only anaerobic life, okay? And what does anaerobic mean?
Without oxygen.
Yeah, they live without oxygen. So we know this because these things live in our intestines, okay?
Oh,
Yeah.
Um,
Yeah, do you see the picture of the nice bacteria there that are in your
the
intestines?
nice bacteria.
wonderful.
Okay, these
There
are
could be life in
anaerobic
space.
bacteria. So they like to live without oxygen. All right. Now they expel CO2. So the atmosphere was carbon dioxide. We got nitrogen, lots of methane, and some water. Okay. Now the oceans were full of iron. Remember how we got all of our elements from the stars, right? Coming down to Earth. Well,
Yes.
iron was the heaviest element. It's on Earth.
Yeah.
Well, if iron rusts, what color does it turn?
Red.
Well, like a reddish
Okay,
brown.
but what does rust mean? So that's in the presence of oxygen. That's iron oxide. There's no oxygen on Earth. So the oceans mix with sulfur and other chemicals, and it turns, our planet had green oceans. So the iron is now green because there's no oxygen for it to turn red.
That's interesting.
Okay, so how did we
Our
get
oceans aren't
oxygen?
red.
All right, so how do we get oxygen? All right, so at this point, there's only about 2% dry land. All right, so the Earth is mainly just ocean. Well,
It's these algae thingies.
that's right. So we have cyanobacteria, phytoplankton, we have our nice little anaerobic bacteria going on. And when they eat CO2, what do they expel?
Oxygen.
Oxygen. So they, have our little waste gas right here after they eat our CO2, and they make these little gas bubbles of oxygen. All right, these are our first photosynthesizers. This is what created our oxygen in the air. Okay, now they're eating up all the CO2. So what's happening to the CO2 levels?
Disappearing.
Dropping.
They're dropping. So we have a lot of oxygen now, eventually over millions of years. And the CO2 levels start to go down. Okay. So now the iron in the oceans have too much oxygen. What color does it turn?
Red.
Red.
Now all of our oceans are blood red. Okay. So we go from green to blood red, right?
Man.
All right, what else happens? So they eat up some of the methane, the CO2 in the air. Now we just have oxygen.
It got cold.
Right, all those greenhouse gases that keep us warm go away.
Yeah, and I believe at this time too, coral appeared.
Okay, interesting. So I would believe it because you have a lot of oxygen. So the Earth gets really cold, and for about 200 million years, it was just covered in ice.
Is this where penguins came from?
Oh wow, Levi.
Okay,
They all had to migrate to South
That's where
Africa.
kingdoms and
They all
The
had to
origin
migrate to
story.
South
so
America.
now we have, all right, guys. So now we have a lot of oxygen. What happens to the photosynthesizers?
They
What do
die.
they-
They died.
Yeah. So they start to die because they've eaten up all the CO2. There's only oxygen left, right?
Yeah.
And so what happens? Now the Earth can actually balance itself out, and we can have our ozone layer back. When they start to die off, we can actually start getting our CO2 back and oxygen, and we can actually get The
But
right.
how are we getting the CO2 back then? Is there other living things?
That's right. So, well, there's other, not necessarily.
The
there's-
penguins are giving us our oxygen.
Penguins are all behind it, man.
My penguins did not come before the
Well,
earth was
well,
created.
if there's no animals, then how are we getting the CO2 back?
Yeah, there's just bacteria, and there are some plants that will start to come in, but that is a great question for geology class when we started.
Penguin plants.
What we would
Yeah.
want to know about our atmosphere is that we get it back, right? So our ozone layer comes back. So we need the right amount of CO2 and O2, okay? And this is how we're actually, life is beginning. All right, so here's our atmosphere. So what does atmosphere mean? What does atmospheric pressure mean?
3D.
How much
So
pressure your
here's an
atmosphere is
example.
putting on your head.
Okay, so basically a column of air, like the
Hello?
gravitational force on a column of air all the way down to sea
Hello, is this
level.
thing working?
All right,
Yes,
this is
Austin, we
super,
all hear you.
this is super cool, guys. So all the way down, so this pressure of a column of air, there is 14.7 pounds per square inch of pressure in our atmosphere at sea level. So
I have
where
a
we're-
small monitor on my head.
All right, so that's a PSI, 14.7 PSI. How much pressure do we exert back? So if that's how much pressure is pushing down on us, the air is pushing down on us, how much are we pushing back?
14.7 PSI.
Well, we have to be, that's right, around 14.7. We're equal. That's why we don't feel the air pressure. Okay,
Oh, Miss Tara,
yes.
is that why we inflate like a balloon in space? We're just pushing out 14.7 PSI.
Oh, you're on the right track, Levi. All right. This is
Here's
also
something.
why our ears pop on an airplane.
Miss
Okay.
Yeah,
Tara,
I wondered why that is.
what
Okay,
if the
so
air pressure was 14.8 PSI?
okay, that's all right. You're also on the right track. Let me continue and then I'll answer both of those questions in the next slide. All right, so let's take a soda can, right? So if anybody has a can of soda or pop or whatever you call it, Coke. Inside the can, they pressurize it to about 50 PSI. The outside air is how much PSI?
14.7.
14.7. So there's more pressure inside than outside. So if you open it, what's going to happen?
Oh,
Dude.
it popped.
Gonna go up.
Yeah.
That's why it's right. And so if you shake it up some more, right? What happens?
It explodes like a
Pressurizing.
volcano.
It's more pressurized.
It's building more and more pressure, right? Okay. So an airplane is pressurized to about 11 PSI. All right. So a little less than what the Earth exerts on you.
Miss Tara,
So
Miss
your
Tara?
ears pop because you're used to 14.7 PSI. So they're trying to equalize the pressure. The liquid inside your ear is trying to equalize the pressure. So that's why you hear that popping sound.
What would happen
in-
if they made that 50 PSI into like a million PSI?
what do you think?
It would be like a small, that's how they make bombs, apparently.
There you go. All right. So here's space. Okay. Space is considered zero atmosphere.
It
it's-
actually has atmosphere and gravity.
It does ish.
It's
But
like 0.001.
we can get into the technical things later, but it's technically going to be considered zero because it has to do with the radiation, and we'll get into that later. So we'll say it's said to be in a vacuum. So you'll hear that a lot. All right. And when something's in a vacuum, we say it has zero atmospheric pressure. Okay.
And
So if you get into
also,
space, you're in a vacuum. So we're exerting 14.7 PSI. So what happens? Spaces has zero on us. What's going to happen? Just like the soda can, what's going to happen to us?
Will explode.
Yeah.
All right, so if we don't have a spacesuit, so what's really important about a spacesuit?
It
keeps
pressurizes you.
pressurized.
You gotta have pressure, man. Yeah, because the liquid inside of you, like your blood.
Oh, it just squirreled through my eyes.
Okay, so you guys want to
Ah.
see?
My stomach
Oh.
gases would just come out through my mouth.
Levi, nobody wants to hear that.
It's gonna
People
it's
see
gonna
that.
boil.
And also,
Everyone, today
so
I'm going.
we also have to pop our ears if we go diving or if we go deep down somewhere.
Let's see if I can.
Okay, everyone, today I'm going to be putting.
Let's see if I can.
Low frames per
It's gonna
second.
boil.
Oh yes, let's
Oh, this
all
is
boil
such a
our
cool
blood
video.
today.
Let me do this.
My
Let's see if
question
I
is,
can-
where did you get that blood, sir?
Yeah. What did you do?
Where did you get that blood?
That's probably just like a water with red dye in
What
it.
did you do
No,
to
it's probably
Bernie?
just like
What you do to your dog?
No. I know what it is. I know what it is. It's that sheep
Action.
blood.
3, 2.
All right, you guys
1.
want to see what's in a vacuum?
It's
What
gonna
blood
boil.
does?
There we go.
Actually,
All right, so this is your
Nothing's gonna
blood
happen.
in
Nothing's gonna
space.
happen.
Here's
Actually, it's just gonna start fizzing.
half an atmosphere in there.
It's gonna
It's
start
gonna
fizzing.
boil.
Lola, that's what I said.
It's gonna
Oh,
start
it is
fizzing.
gonna boil.
I didn't
So
even
if you
know you
get
said that.
From
3
blood, don't watch, but
atmospheres. Don't see any boiling yet, but I'd see the
Juice.
bubbles outside starting to get bigger as the air expands.
Ah.
all right, we're getting close to almost 0 atmospheric pressure.
Okay, we're at 0.1 atmospheres. Oh, I see
Oh.
some bubbles.
I knew it was just gonna bubble up.
Hey, who wants to be that person?
It looks like
Badly, a lot.
soda.
It does.
Holy cow.
It's not soda.
Looks like
Rainbow
Coke.
juice.
What is going on?
It's that bubble. I knew it.
Na 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 na.
That's a blood volcano. That's disgusting.
No, that's
I
like
told you, it will pour out of your eyes, your mouth, and your ears.
It's
Levi?
beet juice.
So I think this is a lot of the
Beet
juice
juice.
is
Those
in
words
there,
out
but
of the
also, the blood is boiling and
That
so
looks
it's
like
just
kiwi
creating
now.
these steam bubbles, but it's so
Oh my
viscous that
God,
it's just
didn't
pouring
expect it to boil
everywhere.
that much.
It's
Yo, I didn't know there was that blood. In the,
Whoa.
there was that much blood in the container, bro.
Holy cow.
Yeah, everybody, let's
It's
all go put
crazy. I
ourselves
did
in
not
a
expect
in a
that, but
vacuum.
it's
All right,
filling
guys,
out the whole
guys.
vacuum
Guys.
chamber.
Oh.
All right,
Guys,
who wants to go to
crazy.
space without a spacesuit?
me.
No,
Me.
exactly. Wait, wait.
That's a
I
great
want to be
question.
cranberry juice.
I'm just gonna hand you a gas mask, and you're gonna go out there.
So
Oh.
nobody wants to go to space without a spacesuit, right? Because that's
I
what's
do.
gonna happen to
I
your
do.
the
Yeah,
liquid
nobody wants
inside of
that.
your body.
Hey, Miss
So-
Tara.
I would think pressure is a little more important than water to me. Because you have about 90 seconds to live with that before your blood starts boiling. Yes.
A minute and a half.
But you'd probably freeze before that.
No.
Maybe you're right. Yeah. If you don't know-
Or you get burned by radiation.
It takes a few hours to freeze, but you burn instantly. I read it in a book.
So you
Awesome.
get sunburned so bad that you just like eradicate yourself.
You turn yourself into a potato chip.
You turn into a no, you turn into one of those like one of them raisins, bro. You're gonna be a raisin.
All right. So now we know how important atmosphere is. We know how important oxygen is. So how does Earth keep us safe? I mean, how does Earth make sure we have all of these things here? I mean, if our atmosphere left, that would not be good. Does anybody know? What is our protection to keep our atmosphere?
Ozone layer.
Magnetic
even
field.
outside of that?
Magnetic field.
Yes, magnetic field. Yes. So our magnetic field keeps us there. So where does that come from? Our magnetic field.
It comes from the iron inside of the earth.
All right. How do we know what's inside of the earth?
Because we just know.
We just know.
No, we didn't. You mean we just guessed it?
We have to discover it.
We
Okay.
just
Yeah, deep
we
down.
made our
So
own
we
little
had to
tiny
have
vacuum.
some-
What do we use? What instruments do we use for earthquakes?
A
Meters, something meters.
stone on a rubber band.
The seismometer.
Yes. All right.
Seismometer,
So
seismic.
these are positioned all around Earth, like all around Earth. And we use these type of waves to pinpoint earthquakes and what's about to happen. But we also use this to see what's inside of the Earth, and see is in quotations, right? Because what we're doing is we're measuring waves. There's two types of waves. They're called pressure waves and shear waves. Okay. Now, the cool thing about pressure waves is if you clap, it's like pushing air. So that's the type of wave. And the S wave is sort of like if you had a slinky and you started moving it across. Okay.
Everyone wants
It's like
Now-
some-
Now, the cool thing about this, oh, no, go sit over here. But the cool thing about this is that shear waves cannot go through liquid. So if you have a shear wave and you do it on one side of the earth to the other, it stops. Like it can't go through something. So that's how we had our first indication that there must be some sort of liquid inside the earth because S waves can't go through it. So then we use S waves and P waves, pressure waves, to pinpoint how much of it we have, where is it, and we can start measuring the different layers of the earth through seismic waves.
So
Okay.
that's how they did it.
That's how they do it. Precise measurements.
I thought
Why
we
is
just
there a
guessed.
picture of quiche and
I thought we sent somebody down there to take pictures.
Oh, the quiche is my favorite way of thinking about the layers of the earth. So the crust.
And,
is
and Miss
sort of
Tara, Miss Tara,
crusty layer. Yeah.
how do we know that it's not
Yeah.
nickel or cobalt down there instead of irons?
Ah, great question. And there's awesome answers to that. So there is nickel down there. So iron and nickel is in the outer liquid core. So the actual inner core is solid.
Oh, because
solid
iron doesn't melt
solid
as
iron.
well.
What would,
or-
The outer core is liquid, okay? And we know that because we know what we should see, what's abundant in space, what we see on other planets. And also we know the chemical makeup of these things and how they're looking via particle wave, right? So wanted to show you, we have a certain density that we can get for different elements.
I'm gonna guess the magnetic field.
All right, so here is
Right now.
what our actual core looks like. All right, so here is the solid inner core, and do you guys see the liquid outer core?
Yes.
Okay, that's what it's doing. Do you see this convection, this spiral motion that the metal is doing, the liquid metal? That's what makes this. That's what makes this type of magnetic field. Okay, this is the convection currents that actually create our magnetic field and protect us from what?
Radiation.
There you go. We got particles, solar wind, all sorts of radiating things that we learned about nuclear chemistry that come from our sun, right?
does
They're
yours have the same magnetic power as a magnetized paper clip or less?
Well, this is a lot of it. So I would
it's
say,
stronger than a bar magnet?
yeah. Okay, so iron and nickel save us from solar wind and particles raining down on Earth, and they actually help keep our atmosphere. So Mars, do you remember if Mars was once a planet that looked like ours, right? It had running water, it had rivers, it probably had an atmosphere for
Well,
liquid
Earth
water.
has a magnetic field, then why are we getting all these iron
No,
asteroids hunting
It
us?
did not have an iron core. Okay, doesn't have that. So eventually the solar winds and rays and radiation broke down its atmosphere. And once the atmosphere goes away, you don't have atmospheric pressure, you don't have protection from any of the awesome nuclear chemistry particles we learned about, right? So all of that goes away. So that was kind of the fate of Mars. So we love our iron nickel core, right? Great protection. All right, so is the magnetic field invisible?
Yes.
No, if you go to some place, you see the aurora, and that's the magnetic field, I believe.
Right, so mostly it is, right? But if you remember this picture, do you see how the magnetic field dips down at the top and bottom?
Yeah.
All right, that's where we can actually see the electrons giving off light, charged particles, right? So this is what we see as far as how light works, and that's called the aurora.
Oh, you know, the Aurora Borealis.
That's right,
Aurora Borealis.
named after the Roman god Aurora, I think.
I've always thought it was named after Sleeping Beauty till I learned about it.
Yeah, that's exactly what I was thinking. It's like Aurora.
All right, so we have all these things that we need for life, right? How do we know how old these things are? Like, how do we know when all of this happened?
We don't. We're just estimating
Half-life.
Yeah.
Okay, how do we
It's
even estimate?
assumptions.
it.
How do we know?
Half-life.
And it has to do with what we learned in nuclear chemistry.
Half-life.
Okay, yeah. So this is where we actually start understanding our last lesson, which is isotopes and radioactive material. Okay, now who can tell me what an isotope is?
An element,
Something like the
a version
difference.
of an element that's either radioactive or bigger than a normal.
An element with a different amount of
Protons
Protons
and
are electrons.
electrons.
Protons and neutrons. That's it.
Neutrons.
That is the only thing a isotope is something that has, let's say, carbon-12, the most abundant carbon on Earth, okay? Carbon-12 means there are 6 protons, which means it's carbon, and then there are 6 neutrons. If the neutron changes, the value of neutron changes, it's an isotope. Okay, so that's it. So we're going to use this to actually learn how old things are. Okay. All right, so here's our chart of isotopes. And I wanted to show you this one because it's awesome. The black line is number of, it's generally the elements, honestly, and the different types of elements you can get. And all the colors around it are all of its isotopes. So there are a lot of isotopes, okay? And there's different ways of decay. So we learned about beta decay, alpha decay, all right? And then we have some stable things. The unstable things are radioactive, okay? That means they just produce or emit a beta particle or an alpha particle or a gamma ray, right? So it emits a radioactive particle is why we call it radioactive. All right, so an isotope again is just the difference of protons and neutrons. If those do not match up, then it's an isotope. Okay. All right, so somebody mentioned half-life. All right, what is half-life? And I ask this because I promise you will do this in high school. You will do this in college. And in fact, I remember doing it over and over and over and over again.
Didn't he
So
look really young in one of the pictures you showed us before?
Well, actually, Half-Life is a video game, so
No.
what is
Great.
Half-Life?
a video
So
game.
Half-Life
What is Half-Life?
So
A video
Half-Life
game.
is basically just you take a certain amount of time, whatever time that you're given, and whatever amount of that element that you have, and during that amount of time, half of it has decayed or something like that.
That's perfect. That's excellent. Yes. So let's say, so here's our example. So let's say we have a bunch of protons, all right? And one half-life, half of them, or no, well, this is a proton and a electron in here. Half of them have decomposed. And then another half-life goes by and another half is decomposed. And another half-life has gone by. So this is 1, 2, 3, 4 half-lives that have gone by. So
Lot of
this
half-lives.
means that this has turned into something else. Okay. Is all this radioactive sample is decomposing, and this is its half-life. All right, so let's do a little better example. All right, so beta decay, if you remember, is when a neutron can turn into a proton and emit an electron or a beta particle. Okay, so emits some sort of particle. Now this can go back and forth, and you'll see here in a second, a proton can turn into a neutron can turn into a proton, and energy is released in the form of particles. All right, so here's our basic example, our hydrogen isotopes, right? So we have hydrogen, deuterium. So here we have one extra neutron. And then, that's right, tritium has 2 extra neutrons. All right, now tritium can turn into helium. Does everyone see that?
Yes.
Okay, all that means is here's the number of protons, and it turns a neutron into a proton by beta decay. Okay, and it turns itself into helium. So we're starting to see how elements are kind of fluid. They can go backwards and forwards and add more protons, and protons turn into neutrons, and neutron, it kind of goes all over the place, right? There are a lot of cool things you can do with your elements. All right, so this is, so yes, we'll play Kahoot later. So neutrons can decompose into a proton and a high-speed electron or beta particle. Okay, so here's a cool example. Let's take this.
Billie Eilish.
All right, so here's our half-life. Tritium has a half-life of 12 years. Okay, so that means it takes every 12 years, half of tritium will decompose into
Helium.
What was that?
Okay.
Do-do-do-do.
Okay, so let's start Elvis. When Elvis was there,
Oh.
right? We have a full tray of tritium, right? Okay, so 12 years go by. Tina Turner is now our latest and greatest singer. Half of the tritium will remain or decay into helium, okay? Then we have the Backstreet Boys, that's 12 years later, and half of that will turn into helium, all right? Now we have 12 years go by, we have the Jonas Brothers. So half of that, so a half plus a half plus a half plus a half. So we keep adding half-lives together to finally we get to Billie Eilish, right?
Yay.
48 years later.
Ooh.
48 years later, and we have 1/16 of our tritium left because it
Elvis Presley to Billie Eilish. That doesn't sound correct.
kept 12, 12, 12, and 12.
Nothing is
It's called
correct.
evolution of music.
So it took 48 years to get our 1/16 of tritium remains. The rest of it has turned into helium. Okay, because it's radioactive and unstable. It does not want to be in that form. Okay, so it will decay and it has a half-life of 12 years. All right, a good example of this is the radioluminescence. You guys can kind of look this up on your own, but like in exit signs, there is no power to this sign. Okay, it only lights up via radioluminescence. So it uses a tritium gas, which emits beta decay. And as it decays, there's a phosphorus film on the outside, which then excites those particles and lights it up green. Okay, so
So
who's ever
it's-
watched the Radium Girls? I think it's on Netflix, Radium Girls.
I watched this. So like in the I think it was 20s or 30s, they just found out what radiation was. And green stuff. So it was like a hot new thing. And so they were putting it on
notes?
don't. It was a fad, all right. And so they were putting it on everything. And the people working in the factories putting it on everything, well, they were putting it with no gloves or protection on. And like they were putting it on their faces, everything. They were eating food with dirty hands. So eventually, like, I believe some of the girls died from the radiation poisoning, and then I believe some got cancer. And
That's
so,
right.
yeah, then you can
Yeah, so
think
they put them on. They put that on clocks, right?
Work rules.
Miss
Hold on,
Taylor,
what rating is this movie?
Oh, you can watch it. It's a
Miss
kid's
Taylor,
film. So
Or-
what I would say is, so they used to paint with radium because they knew how this could glow without any electricity, right? So you could put it on watch faces and you could see the time at night. So it had many uses, but they actually put it on their tongues and started painting with the paintbrush that had radium on it. Now what happens when you have a radioactive material? It's going to decay and produce what?
Radiation.
Right, a beta particle, an alpha particle. Those are then going to destroy, if it's inside your body, it's going to start destroying things inside your body. Okay, so you can get cancer, a lot of diseases, a lot of girls die. But it's actually
use neon now?
Say that again, Grace.
Is that why we use neon now?
Yeah, we do not use this. Yeah, we don't do that
Hopefully
anymore.
not.
Yeah.
That would be bad.
Okay. All right. So let's continue with our atmospheric decay stuff. All right. So we have these cosmic rays coming down through our atmosphere. All right. Some of these stuff the protons can get through our magnetic field and our atmosphere. Now we have oxygen in our atmosphere. All right. One of these awesome protons is going to hit an oxygen atom, and that is going to spallate. Okay, that's called spallation. Pretty important word. You can do this with Flint tools and
Spallation.
stuff. Spallation. Yeah, that just means it's going to break up the atoms and kind of make them go everywhere into totally different things. And what this is going to make is a radioactive beryllium-10. Okay, there's your 10, and a couple neutrons and 5 protons. So that's what's going to happen when a cosmic proton comes down and hits oxygen. So we have radioactive beryllium in our air. Okay. What else is going to happen is one of those awesome little neutrons is going to hit our nitrogen in the air. Now we mainly have nitrogen. So what is it going to make? So when a neutron hits a nitrogen atom, what is it going to make?
Tritium.
Right there, if you can see it.
Tritium.
There you go. Gonna make tritium and
No.
Carbon?
carbon 12. This is
12.
where our carbon 12 comes from, guys. So a lot of our carbon 12 is just a product of a neutron hitting some nitrogen in our atmosphere and creating carbon 12. Okay, so here's an interesting fact. It not only can create carbon 12, it can create other isotopes of carbon. Okay, so here are some of the famous isotopes of carbon. We have carbon 12, which just means 6 protons, 6 neutrons. But we also have carbon 14 that is produced. And that is radioactive, which means it wants to decay, right? So there's trace amounts of this in the air. And carbon 14 is only found in living things. Do we know why
Like
it's only found in
us.
living things? Anybody have a guess?
Nobody knows.
But I forgot the question.
Looks nuclear.
Why do we have carbon 14 in living things?
It's in the atmosphere.
Okay. So let's say here's a nitrogen atom, right? And we have our awesome neutron or proton. It's going to hit it. It's going to make a radioactive carbon. Well, what's also in our atmosphere?
Carbon dioxide.
Carbon dioxide.
All right, so that carbon hooks up with 2 of the oxygens to make radioactive carbon dioxide. Pretty cool, right? All right, so
Nobody answered it.
it
I
is.
wouldn't necessarily say that's cool.
Oh.
I think it's really cool, and you'll see why in a second. Because now we have these trace amounts of radioactive carbon dioxide, and plants, what do they love?
The poisonous
Carbon
carbon dioxide.
dioxide. They love poisonous carbon dioxide, right? So they take in this poisonous radioactive carbon dioxide. Well, who eats plants?
Animals.
Sea plants.
We do, right? So
Um,
then that makes that glucose, radioactive glucose molecule now go into animals. So in every one of us is radioactive carbon 14, okay? And we can only get it by actually eating the plants and things
I should
around.
never eat plants anymore.
Or 14 decays.
Okay, so 1 in every trillion carbon atoms is carbon 14. And that's how we get radioactive carbon 14 in living things. All right, now remember, it's radioactive, so it wants to decay. So it's super unstable. The half-life of carbon 14 is, who can say it?
5,730 years.
Thank you, Grace. It decomposes back into nitrogen 14. So for every one of these, or half of these, it's going to every 5,730 years, half of this is going to decompose into nitrogen 14. Okay.
That's a lot.
So if you're a living thing and you're not taking in any more carbon 14, that means, if you're not taking in any more carbon 14, well, now it's just going to decompose. Okay, so that means you're not eating anything. That means you're dead. Okay, nothing's coming into your body that has carbon 14 in it. So
I
you
don't
have
wanna
a
be dead.
steady amount of carbon 14. So as that radioactive material decays over time, you can tell how old something is. Okay, so let's say you
why
have-
Billie Eilish again?
Yeah, why is Billie
Billie
Eilish?
Because Billie Eilish's present day.
I know,
All
but
right. So if you are a first figurative art, right, and you have all of your carbon 14 radioactive carbon, all right, so this is made by different types of plant material that had carbon 14 in it, right? After 5,730 years, half of that carbon-14 will be gone. Okay, then another 5,730 years, and half of that will be gone. Okay, so it keeps going half-lives away till you get to present day when you only have 1/16 left of carbon-14. So we can date things back around 60,000 years. This one happens to be around 22 something. Who has a calculator with them? I don't have my calculator.
It's
Not it.
22,920.
Thank you. So all you did was add up 1, 2, 3, 4, 5,730 years, right? And that's how many years that thing, or how old that something is, I should say. So 22,000. What was it again? 20.
I already said it. Sure, I'm gonna get one.
920.
Thank you.
22,900.
Awesome. All right, so that's how we can tell something old is with carbon-14. Now we're at a limitation because carbon-14's half-life is 5,000 years, okay? So we can't date things that are super, super old because, well, all the carbon-14 will be completely gone, right? Also, carbon-14 fluctuates, right? Throughout the years. So scientists make sure they account for this, okay, in their calculations. And we can calibrate how much carbon-14 is in the air through tree rings, because trees actually, when you cut the actual tree, you can actually see the rings and how much carbon-14 is measured in there. And then also stalactites and stalagmites. So in caves, we'll have water forming, and we can actually see how much carbon-14 was in the atmosphere at any given time. And so we do have calibrations for this. But all right.
Rings.
So in living things, all right, 1 in a trillion carbon atoms are nuclear carbon-14 in us, okay? So when it dies, the carbon-14 is no longer replenished, and so the levels decrease. So we can actually use special, this is a woolly mammoth, all right? And we can actually tell how old it is by measuring the amount of carbon-14 levels inside the woolly mammoth. All right, and we do this in very sophisticated machines now, all right? So we've learned that we have a lot of contamination, like your skin cells can get in it and contaminate it because we've got carbon-14. The atmosphere contains carbon-14, so you have to actually test this in sophisticated machinery. Okay, to kind of eliminate any contamination. All right, so continuing on atmosphere, 1% of our Earth's atmosphere is argon-40. Does anyone know why we have argon in our air? And it has to do with
gas.
radiation.
Does it like help protect from radiation?
It is a noble gas. All right, so this is a really cool story, and it begins.
Oh, no.
Okay, so here's our argon. I just put all the isotopes on here. Okay, so most of the argon is actually 99% is argon-40, and that's what I mean by when we say argon-40. We've just added up the protons and the neutrons. Okay, here's calcium-40. And you're going to understand why this is very important. Most of the calcium is calcium 19. I'm sorry, is calcium 20, which is 40. Calcium 40 right here. Okay, so 20 and 20 added up to make our mass number 40. Okay, now here is potassium 40. All right, here's potassium 40. It is what?
Where?
It is radioactive. What percentage of all the potassium on Earth is potassium 40?
0.0.
0.0117.
Banana.
That's right.
Small
Teeny
percentage.
tiny sliver. Teeny tiny sliver of this stuff, right?
Not much.
Not much. Okay. And it's in this stuff, this rock called feldspar. Okay. And this is where we find potassium 40. It's radioactive. All right. So,
Someone got a notification, just letting you know.
okay. All right. So feldspar is the common material that contains potassium 40. Now, what's going to happen when we see feldspar? Okay. This is the feldspar rock we found, right? It can go two different ways. About 90% of the time, it does a normal beta decay and turns into that calcium 40 we just talked about. Okay. Well, 10% of the time, it actually does a different decay called electron capture. And we have not talked about this radioactive decay yet. And I think on your little worksheet there, you can put in electron capture. And what this means is this. Who remembers the sodium vapor emission chart? So this is a sodium atom. And do you remember how we get light by electrons jumping from one orbital to another orbital and emitting a ray, right? A ray of light. Well, that's exactly what's about to happen in our electron capture. The potassium takes one electron from the first shell and captures it in the nucleus. How crazy is that? The electron is captured inside the nucleus.
That's just no.
So there, you've never seen this before. Who's ever seen a diagram where, an orbital diagram, where there's only one electron in the first orbital? There's always two, right? Well, one of these is going to go in the nucleus.
Guess what? I found one.
That means it doesn't like it. So the second orbital one says, I'll fill in the space, and it jumps down to the first orbital to fill in that space. And in the process, it emits a gamma ray. Okay. And that's very, very unique. This only happens 10% of the time. So because it's so unique, it's where potassium turns into a gas emitting a gamma ray. Okay. I want to show you where this at. When these feldspar rocks are in lava, okay, what happens when rock becomes liquid? What would happen to the gas?
It would die from it if you breathe it.
So the gas would actually come out, right? The gas can now come into the atmosphere. So where does argon come from?
The magma.
Potassium turning into argon, and then releasing this magma is melted, which then can release the argon gas into our atmosphere. How crazy. So the argon in our atmosphere comes from molten lava from radioactive decay of potassium into argon. Crazy story. Once this happens,
Radioactive?
it's the rock solidifies, right? Okay. So the rock solidifies. So we have potassium 40. Its half-life is what?
A lot.
A lot.
A million.
1.2 billion years. Potassium 40.
Wait, what's the longest half-life of any element?
Oh, that's a great question. We'll have to look that one up. I don't know. All right, so I know we'll talk about uranium here in a second.
Billie
That's pretty cool.
Eilish.
All right, I
Billie
would say
Eilish.
actually, if I was to guess, it'd be a proton, because I don't think we have ever seen a proton decompose. Although we think it can, it just would take the longest amount of time. That would be my guess. So I'm
Hey,
not
Mom.
sure what element yet.
The
Yes.
longest half-life of an element is xenon 124.
Thank you. What is its half-life?
A lot of
18
years.
sextillion years.
Sextillion years. There you go. Okay, so potassium 40 has a half-life of 1.2 billion years. Okay, so we have that lava. The argon has now evaporated out. So we have a rock with just potassium 40. Okay, so now our clock has begun. Okay, if it stays solid, we have, and the potassium is in there. If it's going to decompose, it's going to take 1.25 billion years to do it. So if there's any amount of argon 40 in that rock, we know how old the rock is. Okay, so we'll say let's say one half-life went by. So here's our rock. All right, we have all of our potassium 40 in here. Half of it is gone. Then another half is gone. Then another half is gone. And then another half is gone. So if we have so much argon 40, let's say we have all of this turned into argon 40. We can back calculate using calculus, which you guys have not gone into yet, the half-life of, or how old this thing
think I've
was
gone into
by
it.
going back 4 half-lives. So we can say this rock is 5 billion years old if there is this much argon 40 in our rock.
Miss Tara,
Yes.
is it possible for all of radioactive element to disappear from a rock, or does a number just get extremely close to zero and never completely disappear?
That's a great question. I believe yes. Everything can decay. Yes. And in fact, that's why I mean this is a very rough estimate of this, because obviously it's not going to be it's going to be much more precise than 1/16 of something.
Billie Eilish is not precise.
Well, these are, several billion years apart, right? All right. So that's what happens and how we can actually date our rock, because the gas argon 40 is trapped in here. And the only way it can be present in this rock is through the decay of potassium. Okay, a gas cannot be trapped in solid rock. Okay, once a volcano happens or the rock melts or is shifted, yes, gases can be released. And the argon then gets into the atmosphere. And then the clock starts over again. Or how old something is starts over again. So the
I
Earth,
finished my notes.
1% of the Earth's argon 40 is from potassium minerals that have melted. And the gas argon 40 has released into the atmosphere. The other cool thing, so uranium, how do we know about uranium? Everybody knows about that, right? What do we generally talk about
Usually
uranium?
see
Wait.
We usually talk about uranium.
Like atomic bombs.
Yeah, with atomic bombs.
Is that
There
guy
you go.
holding a piece of uranium?
He is. So this is
Hey, Miss
usually
Tara,
equated
Miss
to
Tara,
nuclear fusion. Yes.
you're telling me that they use a radioactive uranium-238 in bullets and armor
Correct. Yes.
that you wear? You're wearing radioactive material?
Well, it's not okay. So the issue with radioactive material is not the element, it's the decay. and it's the decay when it gets in your body, right? So we're not worried about the uranium and nuclear power plants. We're worried about the beta particles, the actual decay of things.
Yeah,
okay?
but the decay is
So-
still happening.
Yeah, it's still happening. You're right, but it depends on the half-life. How often will it happen? All right. So uranium takes quite a long time. So in uranium-238, what's its half-life?
4.5 billion
billion
years.
years.
That's
Never
right.
mind.
Decay.
Is
Okay.
there uranium 240?
This is another out of a lot of the isotopes and radioactive materials is another way to check on how old things are, right? So
I bet we
zircon
use
uses
uranium.
this. Zircon rock is like a crystal form of rock, and you can absolutely look this up. It's a really cool process. But we know something is really, really old if we start seeing
Mold.
uranium-238 turning into something. And that's something first is alpha decay to thorium with a helium particle, then to proactinium and emitting a beta particle. And I'm going to go through this. This is the process of uranium decaying into what is our
and
final
then to
product
lead.
into lead. And
Use
each of these steps is really cool. And each of them emits some sort of particle, right? So
So we got that
Levi-
4.5 billion years, and then we have like this 1 second down here.
Wow.
that's right. So here is where this is what I'm talking about. This is what we're worried about. Alpha beta particles. So although it takes 4.5 billion years to get to lead, in the meantime, it goes through 14 different steps, each taking a different amount of time.
I mean,
And
like,
we
and then
have-
you got 2 radioactive leads in there.
Yeah, so we have really, this is probably one of the most refined processes we have on dating materials. And obviously we refined it, we make nuclear weapons out of it, right? And this is super important when we go and make nuclear reactors for Mars. So we really have to understand this extremely well to know each step of this process. So it actually takes 14 different decay steps. And I kind of pieced out the periodic table to kind of see it goes from this to this. And all the highlighted ones are the different elements it's actually going to decay into before it finally goes to a stable lead. And we call that lead 206. Okay, so then when we know we can find in zircon rocks, lead 206, we know how much uranium was in there. And we know, okay, well, how many billions of years has this rock been around for uranium to eventually turn into lead? So this is another great way to date rocks. There's a lot of math involved in this. So,
A bit.
and you will definitely do this. I remember this in chemistry 101 at college. To actually do calculating decay rates. So you guys will be doing this for sure. All right, so why is this important? I sort of touched on this already. Why are radioactive decay rates important?
Space suits, cancer treatments, nuclear power, creating atmosphere, stuff like that.
Wow.
All right, so let's say we talked about Mars. We loved our terraforming Mars.
Yeah.
Well, there's tons of radiation going on there. So we really have to understand decay rates really well. We also want to know what happened to Mars. How old is Mars compared to Earth, and what was there, right? So we're going to need, wouldn't it be cool if we could understand radioactive material so much that all you'd have to do is take a pill to where if you were exposed to radiation, you would never get cancer, right? That you could prevent Yeah, you could prevent the radioactive decay from happening. So you would need a spacesuit besides the fact that, well, your blood would boil, but you wouldn't need it for radiation, right?
All you need is a pressurized suit.
That's right. So then growing food. So you guys did when we terraformed Mars, we grew food underground or in, you know, a hut or something I think you guys built. Well, the issue is all the soil is now radioactive, and we also have tons of radioactive materials and carbons that are in everything. So how do we get that out? Because we don't want to eat it, right?
Purify it.
Yeah, so understanding how the decay process works, how to actually prevent the decay and radioactive materials getting in our food is super important. Not just here on Earth, but other places around. All right, and that is our time. We're actually way over time. You guys,
Overtime, yeah.
yeah, you guys did great. You're more than welcome. Is everyone ready for
Time deathmatch?
We have
Yeah,
we have
I'm
68
logging in right
chats.
now.
Oh God.
Okay, I'm gonna go.
All right, so let's see. Kahoot.
Bye.
Bye, Eli.
I'm gonna see if I can start a live game on this. And then, so it's doing that. It takes a extra seconds to load thing, and then I'll use my phone if it's not. I gotta find my phone. I think I used my phone last time, didn't I, guys?
Yeah, because it didn't work or something.
Oh, here it goes.
Lola, what happened to your face?
Okay. Oh,
All right, I'm
um,
going to.
give me a second. Let me.
What's the game pin?
Hold on, just 1 second. It is
Oh.
5 or 7.
Bro.
What?
I want to sit with me.
You do? Okay, buddy.
See, he loves you, I think.
He does. All right, there's your game pin.
Okay.
Okay, great. I have the Kahoot app now, everybody. Wow.
Ooh, nobody likes it.
Ooh.
Okay.
You want to play with me?
How do I get out of a?
I can sit.
How do I do this? I'm so confused. Now it's screen. Full screen now, Mom.
All right, we got 7 players.
I hear the low quality Kahoots song in the
Yeah.
background.
You want me to turn off my sound?
No, I like the
it's fine.
sound.
We just hear
Yeah,
it.
it sounds perfect.
Okay.
I just realized my mic was unmuted.
That's okay.
All right. 9 players.
I'm player 123.
I'm glad.
I think we all know who the pug is. Ashwin,
No, that's not me actually, I swear. I'm monkey.
Levi. It's
I'm
gonna
monkey.
be Levi. Oh yeah, you're always that. It'll be Levi then.
No, I'm.
Yeah, bro, he's
Exactly.
Quandalingo.
And we chose a pug, so
I'm.
15 participants and 11 players. Let me know if you haven't joined yet.
Joined yet.
I did. I joined the app.
I wonder if you have to wear. Oh wow, you have to wear an accessory.
Yeah, you can't.
It doesn't let
wear
you
an
not
accessory.
wear an accessory.
Yeah.
It's like your head looks weird without it. Buddy, hey Emma. What?
Well,
Who's ready to play Kahoot? Me.
That's the most depressing me I've ever heard.
Who's ready to
Me.
play Kahoot?
Everybody play Kahoot. Miss Sarah started.
Haven't joined yet.
How do you join that? I'm gonna start.
Victor's gonna join. Oh, of course, Ariana Grande. Of course.
I'm gonna
Oh
start.
yeah, everybody, we gotta be
All
super
right.
good because we have a celebrity.
Everybody.
So wait, how do you change your name?
Is everybody joined?
Yeah,
Yes. Ah.
Okay, can I start? Yes or no?
I
Yes.
need to change my name first, but I don't know how. so-
Wandale Dingle.
You can't change your name once you try to put
Wandarius
it
the
in.
thing the dingle.
All
I'm
right.
ready.
Perfect.
All good.
It's perfect.
I'm starting.
I love it. It's the best.
Is everybody yours then? Are they
Oh
good?
my
Person
god.
saying that, by the way, was obviously Ariana. Mhm.
What, mom?
Oh,
At home. Just giving some
Wow.
Oh,
I wouldn't be
wow.
taking that as who put
Fortnite.
Fortnite? Really?
Well,
Wow.
Miss Tara, yours is a little behind on the screen.
Do it.
Yeah,
Yours
that's
is
what I
yours is
want.
very
That
behind.
is so
Humans
mean.
do not need to survive. Yeah, it's still on the question.
Fortnite.
Lysol.
Personally, I think
Hey, I took a
vacuum
screenshot of
cleaners.
this.
Miss Tara, is that bad Wi-Fi?
Yeah,
That
it's on
what?
question 2. We're almost on question 3.
I mean, like everyone's already answered the question.
How was
There's
Earth oxygenated?
34 questions.
Aliens brought it to Spike.
No, spider monkeys.
monkeys.
Go with
monkeys.
them.
How about this?
What was that on?
See, I am on the podium.
Damn, in
you
fourth
monkey.
place. I'm monkey. Not
Love how I
monkey's not
missed
gonna
one
be in
question.
third for long.
I'm in 10th place.
10th place.
Eating too
Oh,
many beans. You just
Beans.
eat too many
If
beans.
you didn't answer beans, you're built like a baked bean.
beans.
Beans. Volcano. Because
Volcano.
nobody chose beans. Nobody chose
Why am I
beans.
suddenly in 7th place?
Candy Bomb has the highest answer streak. Oh, that's me. I'm in 6th place.
I was in 4th, now I'm in 7th.
What do we
I don't
know
why.
is inside Earth? Just guess.
Just guess.
That's what, that is the answer. Mhm.
Eating too many beans, bro.
Everybody pick just guess. We do just guess.
I don't know. I don't know.
No! No!
Why are you screaming?
Hey, I'm not in.
Why are you screaming?
What's the code again? I'm not in.
Don't know. Oh,
It's
547
It already started, so I don't think you can
You
join.
can still join in. It's 547 290.
290.
Yeah,
547
547 290.
290.
I'm on the podium.
Yeah, I'm in 4th place again.
Ariana's eating pizza.
Yes.
Yes.
That's Red
It's just you're on the podium.
I know, like it wasn't going for me. Earth and Renfield is generated from large
Earth is
magnets
attractive.
and crust.
Earth is attractive.
Honestly, I think Earth is attractive, so I think that's why.
Yeah.
I don't know.
For some reason, I'm
Yay,
for
4th
some
place.
reason I'm on the question after this. I don't know how.
Wow.
I know,
Oh, we
everybody
all
is.
are.
Yeah.
Ariana.
Oh,
It's
hey,
a
I'm
lag.
second in place. Wow, that's new. Emma, who are you?
I'm the Jericho.
We'll change location.
Yes.
Does my
Only
Yeah,
when
only
it
when
feels
vacation-
sad.
Sad.
It only changes when vacation's in the winter.
Yeah, only
When it feels sad.
I didn't even read the question. I accidentally put no.
No.
Yeah, but I
Yeah,
and I
you
got it wrong.
Yeah.
Wait.
Ashwin, I think it's too late for you, bro.
What
Think
place
too
are
late.
you in?
I can't believe I didn't even read
Ariana,
the
mute
question.
undo your camera.
What interacts with solar winds?
You mean-
Ooh. Fields of
Field of
dreams.
dreams.
Base
FaceTime you.
Earth invisible space
Dream,
zone.
dream, dream, dream,
Dream, dream, dream, dream, dream, dream.
He stole my dream journal. Principal, expel him.
Ruined his
You stole my dream journal.
Principal expelling him.
Hey, I'm behind Gavin.
The principal's office and have him expelled.
Hey, Ashwin, there's your
You
question.
stole my dream journal.
Expelled.
Why do ears pop on an airplane?
You're about to
You're about to
explode.
explode.
You're about to
Nah,
explode.
never
Could explode on the plane.
Too much
This
soda
never
drink.
happens to me.
Yo,
A
you're
bomb
very
threat on the
explode.
plane about how your ears are gonna explode.
I know.
I think it's kind of illegal.
Sir, stop the plane. My ears are about to explode.
Yo, look at. Oh, I wonder who Quandale Dinkle is.
Yeah.
I'm Quandale Dingle.
Wait for
That's Levi.
I have 55 points behind Monkey.
Ooh,
Oh, get wrecked, kid.
man. Hey, read that sea level. Ooh.
It is picture.
I don't know this.
Ooh.
Maybe this one.
Oh my gosh, it's
Well,
M.
why you seem so happy about? I don't know this.
Oh.
I
Yay.
have a free one.
I'm gonna
Come on, get it right, get it right, get it
21.
Oh, I got it right. That's
Oh wow,
I
I
kind of
got
just
it
like
right
chose a
too.
random one.
I
21.
genuinely forgot about that question.
Wait.
Somebody's behind you, Levi.
I
Typical
don't
skill
care.
issue.
I've gone to everyone. I've gone to every
Three.
single one right so far.
Auto-tune?
14.7
Emma, are you still behind me?
Yes.
Oh, L.
And what you say it so kindly, and then you're like,
14 points behind you.
Typical L in my opinion.
I am 300 points behind Miss O.
Says the
You know,
person who
I
didn't
think
even look at
I think Bean Man should be in first
I feel like,
place.
Miss Tara, are you waiting so that they're both in sync with each
Yeah.
other?
I
Yeah.
am,
Xenon.
because we're on question 12. And, for
And
some
And this is
reason-
still in question. This is still in question something.
11.
Let me wait one question here. And
Do
see
the
if
bottom
it-
right one. Bottom right one where the guy
Oh,
farted.
people, how was your day?
Yo, what is this? The guy for you.
Chicken, chicken, chicken. Get your way at Burger King. Like a king at Burger King.
Yo, who chose?
Let's try to nest.
Hold on, just one
Dale
second. buddy.
But is Victor
All right,
playing?
this is it, Miss Tara. This is it. This is it, Miss Tara.
Well, I think we
Wait a minute. I think my game froze.
Oh yeah.
That's
Mine
okay,
mine
person
did
in the
too.
mood.
Oh, shoot.
Atmosphere.
Yo, -2.
Actually, the moon does have a
Negative.
tiny
Higher pressure.
atmosphere.
Plaster
Yo,
imperfection.
it's
I
negative.
got that one right.
I'm in it.
Straight
negative.
Yeah, I'm on the
guys.
podium.
I don't think
It's
I've gotten
zero.
that question wrong yet.
Who didn't choose -2?
I know. Whoever didn't choose -2, you're a goof.
I'm so close behind you.
Oh, you know what? It's gonna sit there because it's recording my past, how I sat there through two things. It's not gonna move.
Oh, that's
Tried
great.
it- I tried to trick it, but it didn't work.
All right, just keep on going then.
Okay.
Oh, what happened? Oh, yay. Turn superhero.
It'll become
Freezes,
invisible.
freezes, it freezes,
It-
it
it-
freezes,
it'll-
it freezes, it freezes,
It
it
becomes
freezes,
invisible. It
it
becomes
freezes,
invisible. It becomes invisible.
it freezes.
It freezes.
Victor got
Ashwin,
it. Look at that.
I'm on an answer streak of 14.
Bro, who's king?
Jeez.
Get one wrong, Ashwin.
I don't
No.
even know how old things are. We guess.
Guess.
Nothing is older than my
Yeah.
grandmother.
We guess. Oh no, that's a straight insult on your grandmother.
You're about to get beat up by
No,
your grandma now.
not
That's
Get
one
one
of the
wrong.
answers. That's
One
so
wrong.
rude.
No,
to
I'm
your
not gonna get one wrong.
grandmother.
I'm too good. You see? I'm just too good.
Bro, who's
Oh, I actually have an
Ariana
answer streak of
Grande?
15 too.
Who's Ariana Grande?
Who do you
Ariana.
think? Who's
Uh,
named Ariana?
9 lives. Everybody, it's 9 lives. It's 9 lives. It's 9 lives.
Dude.
Where's my
Donovan, who do you
mouse?
really,
I'm
who do you
offended.
really
My
think
brother doesn't
Ariana
even
Grande
know
is?
me. How dare he?
Oh, everybody knows you.
Typical
I
L.
mean, yeah.
Typical brother situation.
What?
Typical brother.
Brother forgetting.
Act white.
Oh,
It's your everyday-
ow.
I'm
Got
50
that one right.
Why are you
No, you
screaming?
didn't. Oh, wait, you did.
Yes, I did.
Turns
Oh my god,
into
my little sister.
Infinity Stone. I want to have an
Oh my god, is that a Marvel
Infinity
reference?
Stone.
I don't.
I think it's a Marvel reference, guys.
I want to be. I want to have an.
I'm gonna get this one
Infinity
wrong.
Stone.
Oh nope, I didn't because I'm just too good.
Got it wrong. No.
Yes, Ashwin, believe in yourself. You're just too
Why
good.
is player 123 a streak with 13 questions when I have 17?
I'm really good at
Oh,
this
I
game.
have a screenshot of this.
I'm play 123. I'm really good at this game.
Billy
Oh my
Eilish.
gosh.
Oh.
I have failed. I have
Big
failed.
aliens.
I have failed. I'm
It's
so
It's
Billie
on the
Eilish.
sad.
picture, guys. I mean,
It's a
I'm so
Billie Eilish.
sad.
Billie Eilish, that's what we
Billie
get, guys.
I'm
Eilish.
so sad.
Yeah.
that's what
You
you
monkey!
get.
You monkey! Bro, you monkey! Emma! Emma!
Why is produced by
Yes.
Aquaman?
Glow sticks! Glow sticks! Glow sticks!
Bioluminescence.
No.
No.
No. It was right. Ah.
Oh, bro, I got it wrong too. I got it wrong too.
19. I
You're
got
lucky,
it.
Emma. You're lucky.
Hee hee. Emma, see, we're the smart kids. We got it right. We
You're
take
straight
notes.
L.
I got it right too.
Oh, well, you should have said something. I would have called you smart. Love potion 9.
Love
Love potion 9.
Ooh.
It was the.
Can I have it?
Oh,
I just love potions. Love potion. If you don't pick love potion, you're gonna get it wrong.
wait. It was.
Oh, wait, now I know.
Every
No.
Well, I have an answer streak of 20.
I've gotten every single question.
How many points
Yeah.
are you behind me, Ashwin?
I think I
behind
might have
somebody
just
else
skipped
now.
a question.
Oh,
Fragments of
wow.
material. Wait, who are you behind?
I don't know.
Vacation. We're going to opinion.
Yo,
on
it's
it.
vacation. It's get a life, bro. The time it takes for half the radioactive samples
Vacation.
making those. Get a life.
Austin, who are you behind?
Oh, it's Legend.
Can
Yeah,
you-
answer
I don't
sheet
even know.
21.
I don't even know.
Okay, yes.
Bro, bro, stop it. No.
It was.
Oh no, I think I got it wrong.
I don't think we got it.
Yeah, I got it wrong. I believe so.
Oh my god! You monkey!
Mommy, that's the green one.
I was so low. I was so
No, it's the green one.
Which is a radioactive form of carbon.
How did I?
Charcoal toothpaste. Charcoal toothpaste. Yo, it's Billie Eilish.
Black Dog Big
Maybe the red one.
I can't spell her last name though. It's so
Eyelash.
like no, it's not how you spell it.
It's eyelash.
How
Billie
dare you? I'm so
eyelash.
really Billy
Why am
Eilish.
I not in first place if I got all the answers right so far?
You have to do it at a certain time.
Oh.
It's also who's the
No,
fastest.
monkey, I got it wrong.
Typical skill issue.
Yo, Emma, I feel like everybody just heard you scream that.
Oh, I got it wrong too. Oh, I'm.
Yo, it was
1,025.
20 years.
That's not right.
It was
I'm
3,
way
7,
behind you,
20.
Emma.
This is
I
rigged.
don't believe so.
This is rigged. How am I still behind these people? I've been behind.
Yo, it's carbon 1,
A
everybody.
pile of trash.
The
It's
answer is in
carbon
the
one.
image.
Nah, bro.
It's
I
carbon
hit.
one.
I put carbon 1 on accident.
Yo,
Of
what have
course
you
you did. Of
done?
course you did. Of course you did.
Oh
And
my
now you
god,
put
bro!
everyone
I'm
with the
gonna
wrong
blow up.
answer.
Do, do, do,
You
do.
gotta be serious right now.
Just imagine.
Agree.
Oh my god.
It's in the. I think it's in the picture. I didn't look at the picture because I knew the answer, but it's probably
It's
in the
one in
picture.
every 0,0,0,0,0.
Hey, stop it! Stop it! Stop it! You can't tell the people. You can't tell the people who don't know the answer. The answer.
million.
That's cheating.
You can't tell the people anything.
Oh my god, I got it right. Now I'm behind somebody.
Yeah,
I'm tied with
got it
somebody.
right. I'm on a 26 answer
That's
sheet.
one of them of 0.
Carbon
Who's
14. Emma, that's a really vegan picture, don't you think?
After you are sit back to level 1.
You know you just offended my entire race.
I mean, like you
But
said
yes.
it during the lesson. Your mom chose the picture.
Well, I'm
Well,
literally.
we're
gonna
not
quit this
eating the
game.
woolly mammoth.
Well, yeah, but like you said all.
I don't know, man. That was kind of goofy.
Which
Yo,
one?
Lola.
Oh, it looks like Gavin's in first place.
Wait, really, Levi? You were knocked out. Ooh. It got quiet, like silence,
Who's,
but not really.
Wando Bengalius.
Who's Bean
Oh,
Man?
I'm slowly
I
on
am
track up
Bean
to the back to the
What
top.
place are you in?
I
Slowly.
am Bean Man.
Yo, I literally get one question wrong and get knocked down like 6.
Anybody else
I don't
realize
know.
how loud Oswald is?
I'm talking
Yeah,
very
my
close to my
phone.
mic.
It was the capture.
Yeah, I think so.
A selfie.
I'm having a cold sweat.
Wow, the one on the screen is so far
Hey,
behind
thank
us.
you, Victor, for telling me the answer.
Overshare.
I'm in 4th place. Ooh, I went down. Why is that person sad? I'm at least on the board. I mean, all the times I end up in like last place or something.
All right, 4 questions left.
Wow.
It's 30 minutes, guys. All right.
Yeah.
30 minutes.
Wow.
I can't believe it.
Jeez,
Bro, I get
30
one
That
thing
was-
Oh,
wrong.
I'm
you can
behind
carry
Leslie
it.
and Desi.
We did it.
Lexi and
I'm
Desi.
behind Graydon N.
Oh, yeah, we know that person.
I'm behind Monkey.
Oh my gosh, yes, it's totally that person.
Bro, who is that?
It's
It was.
It's a Muppet.
It
It's
is
a
a
Muppet.
Muppet.
I think it's actually from
Muppet
Sesame
Babies.
Street. It's from Sesame Street.
Can you tell me how to get to Sesame Street?
I don't know.
Yeah, you just you hop in the back of this nice light van.
Nobody knows Fraggle Rock.
Honey.
Oh.
Wait, bro, it's honey, bro. I gotta be
Alright,
honey.
alright.
Wait,
Austin, so
Wow, they were quick.
a black SUV will drive up to your house and you will have to hop into it, and it might take a couple
my
of
God.
days.
One more.
One.
Steps.
Steps. A
They're
drop.
200.
14.
No. It's the
Great.
step. It's like the actual step.
Yeah.
14.
Bum,
And
bum,
to count how many there were.
You know, Miss Terry's gonna stop the screen share, but it's not gonna let her because the thing's so behind of what we've done.
Yeah.
It must have been because
It must
somebody joined
one, two,
later, so
three.
it
Yeah.
It must have been a waiter.
Last
Alright.
question.
Favorite type
Favorite
of
type of
space
space
food.
food?
Just click anything. Click anything.
Okay,
Peanut butter on tortillas.
Dehydrated shrimp spicy sauce.
So all of those are real space food.
Like shrimp.
Yeah, just pick a random one because they're all correct.
Delicious.
Peanut butter on
Dehydrated orange
tortillas.
juice?
Yeah.
How will that work?
Oh,
Bro,
we got
how did
lots.
I
I like
fail
dehydrated
one
oranges.
question?
Good.
I was in 6th place. I was like one thing behind. Why am I a chicken with heart eyes? I mean, like
Oh, skill issue.
my screen's just showing a chicken with heart eyes. You know what? You know what?
Gavin N wins.
Gavin and Will. Place.
Runs up.
Bro.
Bro,
I'll
this is
keep it on
good.
here until the other stuff catches up to our thing.
That proves how hard it is to win a Kahoot. You get one question wrong and boom, you're gone.
I know,
Well,
right?
you got some good players that you're playing against.
Wait
That's
a
what my
minute.
screen showed me. Just a happy little chicken.
I think I got the biggest answer streak overall.
I
You might-
missed
yeah.
on like 22 or something.
Everyone, on our next Kahoot game, we need to be the mole people. We need to
The
have our-
mole people.
Yes.
The mole
have
people?
our mole names.
The mole people.
Oh, I
It-
call being Moss.
Hey, Miss Sarah, we should do one of those castle ones again. Those castle Kahoots.
Yeah. Can I make one?
That was terrible.
I don't think I was there.
No,
I don't
Lola, you
think I
cannot
was
make
there
them.
for that. Well, now that we're kind of talking about cahoots and we took a poll at the beginning of class on whether we wanted to do the science quiz bowl. So I can actually send out like a bunch of questions to study. And then we can break up in teams next time and do a team Kahoot quiz bowl if that's what y'all want to do.
Mm.
Do that.
I kind of want to do that.
Okay.
Don't
But
worry.
I don't know what the castle one is. Is that where it's like
Oh,
a
that's
game
it's a
or
special
joint?
type. It's a
Yeah.
special type of like I don't know.
Yeah, no, I think I saw different ones, so I can go
Oh,
through and kind of see what we could do. We could do teams, or we could do, like you guys said, the castle one or something, and kind of round out our nuclear physics class with like a cool team quiz bowl thing. I'll put all these Kahoots. I created like a Kahoot course called Nuclear Physics for Kids, I believe. Or it's
Yeah,
called
it's you have
Genius
to.
Science.
You already told us that is the age limit of 12. So
Oh no, that's the first one I created. I created a second one that's a course instead of a study.
it's not on your page.
It is on our Facebook page. I'll have to
Okay,
make
because just my
sure.
mom didn't put it on there. She has her study group, but that's it.
Oh, your
Okay,
face
I'll-
keeps freezing.
Oh, that's because I'm looking on the Google Classroom for the thing.
Oh, I'll put it on the
Classroom?
Google Classroom. Yes, I'll
I
put
don't
it
have
on
that.
the link to, it's on Kahoot, and I think you can look it up as Genius Science Academy. And it's
Oh,
our
I can get
nuclear
it.
physics class, and it's a course, and I'm putting all of our Kahoots, our past Kahoots on there. And I'll probably use that and combine a lot of them for the questions for the quiz bowl, and then you can study that. Will that be cool? Because then you could practice on Kahoot for your questions.
Yeah.
Yeah.
Okay. All right. It looks like the screen has finally caught up with us. You guys want to see the results?
It's peanut butter on tortillas.
So I must admit, all of these that I put for food, space food, are actual space food you can pick as an astronaut.
No, that's kind of disgusting.
I chose freeze-dried orange juice. Wait, are any
I
of them
chose
correct?
the beefsteak sterilized with ionizing radiation.
I chose the peanut butter tortilla. Tortilla.
Peanut butter tortilla.
Hurricane Katrina. More like tortilla.
If y'all are looking for books to read that are fun, Desiree has read this one. In Naturals.
On Naturals.
It's about
Oh,
like humans destroying the earth and what did you say?
Oh, wow.
Radioactive.
So basically, humans have polluted the earth until they can't, to the point where animals have had to evolve to live on it properly and eat trash that we throw away.
What?
Oh, that's
It's
pretty
like-
cool.
Isn't that already happening now?
Such
Yo, isn't that the definition of raccoons?
Oh wow.
no, like
I think it is.
sharks find trash delicious. There are eagle dogs, butterfly snakes.
Eagle dogs?
Eagle
That's
dog.
a-
Butterfly
terrifying.
snakes.
Funny.
You know, every time someone says butterfly, I think like, Alice in Wonderland, the butter that's flying.
Yeah.
You need
The
help.
butter
There's a
flying.
little bit of radioactive decay in the book.
All right, so hold up the book again. What is it called?
Unnaturals.
Unnaturals. All right, cool.
In naturals.
Well, I'm going to stop recording right now. Is there any other questions?
Nope.
Oh,
Yes.
if you vacuum up wet things in a vacuum cleaner, how come